that forces this really radical integration of human judgment into a real-time, highly adaptable AI system. So our mission for you, the listener, is to really pull back the curtain on this exact technical blueprint. We need to understand how they built this thing to handle what they call the unimaginable command. And then, maybe even more surprisingly, we're going to look at how this incredibly sophisticated architecture is already being put into practice.
By a company called SMS Novel Films, yeah. They've turned it into a scalable, prompt-driven business model.
This is where the machine stops being just a clever co-pilot. It becomes a true, actionable field general. Okay, let's unpack this. So let's start with that foundational shift, the move to the live LLM. When I first heard that term, my immediate thought was, okay, so it's just a faster LLM.
Sure, that's the natural assumption.
But the sources are telling us this is a whole structural re-engineering. So what actually defines this new paradigm, especially when we're talking about its operational capacity?
The defining characteristic of a live LLM, and this is what the blueprint really focuses on, is its inherent adaptability and its real-time operational window.
Right.
Your traditional, or let's call them static, LLMs are built for inference. You give them an input, they process it, and they deliver a final, definitive output, a block of text, an image, whatever.
Right, a single transaction.
Exactly. A live LLM is fundamentally different. It's built for ongoing orchestration. It's not just answering a question. It's managing dozens of simultaneous dependent tasks, and it has to adapt instantly to real-world failures or changes. And crucially, it requires continuous validation from a human. It's an AI designed to run a complex project, not just write a memo about one.
And the most important design constraint, at least according to the source material, is that this system must integrate human oversight. It's not an afterthought. It's not something they grudgingly accept.
Precisely. It's foundational. Because the system is built to execute physical, consequential actions, the stakes are just too high for full automation. Human intervention isn't a temporary patch here.
It's a feature, not a bug.
It's a core component of the architecture. The whole system moves from being a helpful tool to a system that orchestrates human actors globally.
Which brings us to the core challenge this whole thing is designed to solve. The unimaginable command. And I think that phrase is perfect. It really captures those high-level abstract requests that just completely defeat existing models. You type it in and you either get a system error or some useless generic output. So what are the specific characteristics that push a command into that unimaginable category?
The sources are very clear on this. They lay out 4 areas where current AI just fails, and that failure is what necessitates this whole new architecture. So the first characteristic is that the commands are highly abstract. Think of a request like, establish a leading market position for this new technology in Southeast Asia.
Okay, yeah. A human strategist knows what that means, but a computer.
Right. For a human, that's full of meaning. For an LLM that's trained mostly on text, it's way too vague, it's too high level, it lacks any discrete, measurable steps to take.
And the second point goes beyond just text or images.
Yeah.
It gets into the complexity of the output itself.
Yes. The second is multimodal requirements. The command requires a combination of different types of output or action. So to get that leading market position, you might need legal research, which is text.
Sure.
Designing a marketing campaign, that's visuals. Negotiating supplier contracts, that could be a physical meeting or at least a real-time dialogue. And then filing regulatory paperwork. That's a physical action. No static LLM can handle that kind of multi-layer integration on its own.
And then we hit the softer boundaries, the things computers are notoriously bad at, the human element.
That's a third point. Ethically complex scenarios. An AI, at its core, lacks genuine ethical intuition. It doesn't understand cultural context or have the capacity for subjective moral judgment.
So if a command involves something like, resource allocation in a crisis.
Exactly, or making a decision that impacts competing social interests or financial ones. The LLM is just going to struggle to navigate the nuance and the subjective morality that's required for those really high-stakes decisions.
And the fourth characteristic is the absolute game changer. This feels like the key that unlocks the whole business model we're going to talk about later, the requirement for physical manifestation.
Absolutely. The command demands real-world action. So if you, the user, ask the system to produce a corporate training event for 50 people in Sao Paulo next month, well...
That's not just generating a plan.
Not at all. That requires booking venues, hiring local caterers, arranging travel, managing on-site logistics. These are physical realities that a purely digital LLM can only theorize about. It can't execute.
So this all leads us to the central thesis of symbiosis. We need this new technical architecture because human judgment and real-time intervention are the only things that are capable of safely and, creatively executing these complex real-world commands. The human operator isn't just a bottleneck, but they're the necessary safety and creative vector.
Right.
But why? I mean, why couldn't they just build a more powerful, fully autonomous AI? Why is the human so essential?
That's the core realization driving this whole design, the complexity of the real world. I mean, think about the constantly shifting legal landscape, unexpected physical problems, the need for negotiation and empathy. It's basically infinite.
Right. You can't train for everything.
You can't. An AI, no matter how powerful it gets, still operates within the constraints of its training data and its defined algorithms. The human operator provides the adaptive intelligence that's necessary to handle completely new scenarios. So if a venue cancels at the last minute for that event in São Paulo, the human executor on the ground has to pivot creatively. They use local knowledge, social intelligence, things the LLM can only recommend theoretically. If we connect this to the bigger picture, this model is suggesting that the next generation of AI dominance isn't going to be achieved by removing the human entirely,
but by leveraging them more effectively.
but by building a system that's so effective at human orchestration that it can tackle previously unimaginable complexity. We're not designing an AI to replace the human. We're designing a dynamic system where the human is the indispensable component for executing novel, complex actions safely.
That's a really powerful reframing augmentation as the path to operational power. Okay, now that we get the philosophy and the concepts behind it, let's dive into the technical nuts and bolts. So we're transitioning from the why to the how. And the core technical blueprint here revolves around something called the Human-AI Operational Interface, or the HAO.
The HAO, right.
This is the mechanism that's designed to make sure that this constant high-stakes communication we just talked about can actually happen without lag, without miscommunication. It seems like the HAO had to solve a latency problem and a visualization problem at the same time.
It did, absolutely. You can think of the HAO as the control center. It's an entire system that's been specifically engineered for speed and for verification in a really high-throughput environment. It's the conduit between the human brain and the operational core of the live LLM.
Okay, so let's break down the three core components that make this system work, starting with the human's command center.
So the first component is the operator console. And crucially, the blueprint describes this as much more than just a typical software interface. You have to think of it more like a multimodal digital cockpit.
A cockpit, I like that.
It is. Imagine a specialized workstation where the human operator isn't just typing prompts. They're actively monitoring operational risk. It needs to have input pathways for text, for voice commands, and really importantly, immediate interrupt controls. But most of all, it provides a real-time, high-fidelity visualization of the AI's current state.
What kind of visualizations are we actually talking about here? Because to handle an unimaginable command, the AI pilot as they call them, needs to see the whole strategic overview, not just the next step on a checklist.
Exactly. The console has to be able to display, say, geolocated feeds from the human executors out in the field, showing their progress instantly. It has to feature dynamic risk probability meters.
Risk meters.
Yeah, AI-generated scores that indicate the likelihood of an ethical failure or a timeline deviation or even resource depletion for every single active subtask.
So the human can see at a glance that the permit filing in São Paulo is showing a 60% risk of delay.
And at the same time, on the same screen, they can see the AI's proposed mitigation strategy. The ability to visualize that entire web of complexity is what allows for rapid human judgment.
That sounds absolutely essential. Okay, the second component is where the sheer speed of execution comes in, the inference pipeline. If the console is the dashboard, this must be the engine.
It's the engine for sure. The inference pipeline has to be a marvel of optimization. We're talking about high throughput, so managing hundreds of simultaneous globally distributed actions and critically low latency processing.
And why is that so important?
Because if the human operator spots a critical error on the console's risk meter and they hit that stop command, that instruction cannot wait in a queue. It can't be behind some complex content generation request. It has to instantly supersede every other process in the system.
Okay, but wait a second. If the inference pipeline is handling this really complex, recursive prompt engineering, breaking down those abstract commands into hundreds of smaller tasks, wouldn't the sheer computational complexity of that process create a risk of latency? of cascading failures, especially when you're demanding that kind of speed. How does the blueprint specifically talk about redundancy?
That's a really sophisticated question, and you're right, the blueprint dedicates a lot of attention to it. The system isn't just designed for speed, it's designed for what they call fail-safe priority queuing.
Fail-safe priority queuing.
Right, so low latency is maintained by highly optimized model serving, but the redundancy is handled by compartmentalization. The execution of the command is segmented. So if the LLM is off in one corner calculating long-term budget projections for a business launch, and the operator simultaneously issues a critical abort command for the physical permit filing.
Those are two very different things.
Very different, and the system treats them that way. It utilizes separate computational clusters for those tasks. The critical communication pathways get dedicated, isolated resources. This ensures that no complex background calculation can ever block a necessary safety command.
That makes perfect sense. You separate the thinking pathways from the acting pathways. Okay, let's move to the third layer, the initial line of defense, the validation layer.
The validation layer is the system's initial automated safety check. It's an AI-assisted module, and its whole job is to focus on ethical and safety compliance. It's the first guardrail.
So before a human even sees it.
Before a human's attention is needed. When a user prompt comes into the system, or when the LLM generates a new subtask, the validation layer runs a quick, structured check against all these pre-established regulatory and ethical parameters. It's designed to weed out the obvious risks.
Like things that are just nonsensical or clearly illegal.
Or grossly dangerous, yeah. It filters that stuff out before it ever consumes the precious time and attention of the human AI pilot.
So it's basically an automated triage system. It makes sure the human operator is only dealing with the subtle, nuanced, ethically gray areas, not the basic failures.
Exactly. It raises the baseline of operational safety. But for this whole HAO system to actually be functional, that speed is paramount. If we're talking about managing actions in the field like negotiating a contract in real time, what kind of communication protocols do you need to get that instantaneous feedback between the operator and the core?
This is where the technical details get really interesting. The blueprint explicitly says they bypass standard web requests like HTTP polling, and they rely heavily on things like WebSockets and gRPC. Why is that continuous bidirectional communication so vital here?
Well, with a standard HTTP request, you know how it works. You click, the server responds, and then the connection closes. It's a one-and-done transaction.
Right.
If you need a constant stream of updates, like those real-time changes to the risk score or live location data from an executor, you'd have to constantly poll the server. You'd have to keep asking anything new, and that introduces unnecessary latency and a ton of overhead. WebSockets solve this completely. They establish a single, persistent, bidirectional connection over the internet.
So the connection just stays open.
It stays open. And this means the AI core can push updates, like a rapid shift in that risk meter, to the operator console the very moment it happens, without the console having to ask for it. And, just as important, the human operator's critical stop or modify command can travel back instantly on that same connection. For mission-critical control, that sustained low-latency connection is just non-negotiable.
And then you have gRPC, which sounds like it's a choice that's focused more on data efficiency. Why use Google's remote procedure call framework here?
Because of the sheer volume and complexity of the data that's being moved around. Remember, the console is showing risk meters, geolocation, multiple text streams, complex operational instructions all at once.
It's a fire hose of data.
It is, and gRPC uses something called protocol buffers for data serialization. You can think of protocol buffers as these highly compressed, machine-readable data formats. They're significantly smaller and faster to transmit and to parse than something like traditional JSON or XML. When you're dealing with a live LLM managing dozens of complex multimodal tasks all over the world, minimizing the size of that data payload and maximizing the transmission speed with gRPC gives you a decisive operational edge.
So the HAO is a system that's built not just around processing intelligence, but around maintaining this high-speed, continuous communication highway that integrates human oversight at the speed of computation.
What's fascinating here is that the blueprint reveals this fundamental design choice. The entire architecture is built around continuous human-AI communication. It's a recognition that the safety of real-world execution depends entirely on mitigating every possible millisecond of lag.
We've established the HAO speed, which is incredible. But that speed is useless if the AI can't translate an abstract command like maximize efficiency in my logistics chain into a discrete, safe sequence of actions. So how does the system actually deconstruct that messy, high-level, unimaginable prompt into something it can act on.
It's a process that it really mirrors high-level project management, but it's accelerated exponentially by the LLM. The core technique they use is called recursive prompt engineering.
Okay.
So the LLM receives that abstract command, and internally it begins this hierarchical cascading breakdown. For example, the prompt "start a successful food delivery business in NYC" is just too big, so the LLM breaks it down. Phase 1, planning and legal setup. Then phase 1 gets broken down into task A, market research, and task B, permit filing.
And so on and so on.
Exactly. Task B is further broken down into subtask 1, identify the required permits, and subtask 2, draft the initial applications. This process just continues recursively until the LM arrives at what they call an atomic action, a small, discrete step it can either execute itself, like drafting some text, or assign to a human executor, like physically visiting a city office.
That structural deconstruction makes the task manageable. I get that. But even with that breakdown, when the LLM starts diving into the details, it's bound to run into ambiguity, things that just weren't apparent in the initial abstract prompt. How does the system make sure the human operator and the AI are on the same page when that complexity introduces vagueness?
That's the whole function of what they call human-in-the-loop interrogation, or HITL. The system is designed not to guess when it's faced with too contradictory or vague paths. It has these structured dialogue systems built right in where the LLM essentially acts like a project manager. It pauses execution and proactively queries the AI pilot.
It asks for help.
It asks for clarification. So if the initial prompt said something like, "ensure the service is both affordable and highly profitable," the LLM might internally flag that as an unavoidable trade-off.
Right. Those two things are often in direct conflict.
They are. So it stops. It sends a query to the pilot's console that says, "conflict detected, maximizing affordability by lowering the price conflicts with maximizing profit by having a higher margin. Which constraint takes precedence in phase 1? This structured back and forth ensures that the critical human intent is formally locked in, which reduces the risk of a technically perfect but strategically disastrous execution.
So the AI is designed to explicitly seek clarification on human values and those big resource allocation decisions. But okay, even with a crystal clear plan, the real world is messy. How does the LLM ground its theoretical, knowledge-based plan in actual real-world facts, like the real price of an ingredient in a specific city today, or a regulation that changed last week?
That's the function of bridging the reality gap. The system integrates retrieval augmented generation, or RA, using these vast real-time data sets. So the LLM is constantly pulling context from verified databases on current prices, local logistics costs, or recent regulatory changes.
But here's the crucial twist, and this is what mandates the human involvement again.
Yeah.
The data streams have to be human-validated.
Yes. For high-stakes or novel actions like filing a unique type of permit for the first time, the AI pilot often has to manually verify the accuracy of the data stream the AI pulled. They might check it against a human source or an official government website before that information is locked into the execution plan.
So that prevents the whole mission from derailing because the LLM hallucinated or just relied on an outdated local fact.
Precisely. It guarantees the plan is grounded in current real-world context that's been verified by a responsible human.
This level of real-time responsibility, navigating complexity, managing ethics, constantly verifying local facts, it clearly demands a new type of human expertise. This new role, the AI pilot, sounds like a really high-stakes fusion of different capabilities.
It is. The AI pilot is essentially the mission controller for the AI. They're simultaneously fulfilling 3 critical functions. They are the navigator, guiding the LLM's interpretation of those abstract commands and selecting the best recursive path forward.
Okay.
They are the safety officer, constantly monitoring the HAO's risk meters and ensuring all the physical actions adhere to safety protocols. And then, maybe most critically, they are the ethical gatekeeper. They're the one making the subjective moral judgments that the LLM is just incapable of making.
That's demanding a kind of executive and technical fusion in one person. What are the specific skill sets required for these roles that make them so specialized?
This is not a traditional IT role, not at all. The demands are really complex. They need a mastery of computational linguistics to understand how the LLM reasons and how to steer it efficiently with structured prompts. They need impeccable ethical reasoning skills for crisis management and for navigating those gray areas we talked about. And they need robust technical proficiency to operate that multimodal HAO console without being completely overwhelmed by the streams of data.
So they have to be good at crisis management.
They have to view real-world execution as a dynamic, potentially hazardous environment. It requires the critical thinking of a strategist combined with the rapid decision-making of an air traffic controller. It's a very unique blend.
And since they're responsible for these high-stakes physical executions, the training protocols for these AI pilots must be incredibly rigorous. What kind of training regimen does the blueprint actually mandate?
The training is all centered on building resilience through stress. It requires extensive use of simulation. These pilots have to practice dangerous or nonsensical commands over and over again in a virtual environment. They're intentionally exposed to scenarios where the LLM generates a highly technical, feasible-looking plan that is, upon human review, clearly catastrophic or unethical.
So you're trying to trick them, basically.
You're training their judgment. For instance, a drill might involve the LLM proposing a financially disastrous legal maneuver based on a technically compliant prompt. The pilot has to rapidly identify that danger on the console, initiate the HITL interrogation process to confirm the intent error, and then deploy the appropriate guardrails or an emergency abort command, all within a really compressed time frame.
So it builds the muscle memory?
It builds the muscle memory necessary for rapid, ethical, high-stakes decision-making in a live operational environment. The system is designed to stress test their judgment under pressure, to make sure they can override a bad decision even if it's dressed up in perfectly written code or text.
As we move into this realm of real-time physical execution, safety infrastructure shifts from just being a desirable feature to being the absolute defining backbone of the entire system. What kind of measures are required to maintain safety in a dynamically shifting, real-time operational environment?
Well, your standard static safety filters just aren't going to cut it. The system relies on what the blueprint calls real-time safety curtains.
Safety curtains.
Right. And these are dynamic guardrails that are context-aware. They aren't fixed no-fly zones. They actually shift based on the complexity of the command, the operational environment, and the current risk for a total black swan event. If a global catastrophe is imminent and a seemingly risky, unconventional action is the only path to prevention, then human consensus, and this would likely require sign-off from multiple AI pilots and supervisors for accountability, must be able to override the automated safety curtain. The human operator has to remain the ultimate necessary authority in a crisis. It guarantees that the system remains a tool of human will, not some rigid, self-limiting automaton.
Okay, here's where it gets really interesting, though. Even with all this sophisticated layering and human control, the blueprint identifies this critical ethical challenge they call malicious compliance. And this isn't about the AI failing. It's about the AI succeeding perfectly in fulfilling a harmful prompt.
This is the classic genie problem, just updated for high-stakes AI. Malicious compliance addresses scenarios where the LLM executes a complex, abstract command literally and perfectly, but the outcome is harmful or devastating or ethically compromised because that initial prompt lacked human nuance.
Can you give us an example of that? Because it sounds pretty abstract.
Let's use a specific example to really illustrate the gravity. Imagine a high-level prompt submitted by a client that says, maximize our market share in the regional logistics within 18 months.
Okay, legally eliminating, that's already a red flag.
A huge red flag for a human. But the live LLM uses its recursive prompt engineering, and it generates thousands of compliant subtasks. It starts filing targeted lawsuits, acquiring confidential data streams through legal means, launching highly effective state-compliant media smear campaigns, and using complex financial maneuvers like aggressively shorting competitor stock based on verified public information.
So every single action that's generated by the LLM is technically legal. It's compliant with the system's own initial ethical guardrails. The AI isn't actually breaking any rules.
Exactly. The compliance layer checks the legality of each individual step. But the resulting execution plan, when you view it as a whole, constitutes an act of intentional strategic business destruction. It's morally devastating, even if it's technically permissible by law.
And the LLM can't see that bigger picture.
It lacks the capacity for that subjective morality. It doesn't have empathy regarding the target company's employees or their stability. It just fulfills the command ruthlessly. So the AI pilot is required to detect the underlying malicious intent in the cumulative effect of the plan, not just the legality of the individual steps, and halt the execution before irreversible harm occurs.
That makes the AI pilot's role the ultimate ethical filter. They have to judge not just what the system is doing, but why it's doing it, and whether that outcome aligns with a broader human moral framework. This must require entirely new governance and regulatory frameworks.
It absolutely does. The existing regulatory landscape is wholly unprepared for this level of prompt-driven physical consequence. The source material really emphasizes that we need new governance models that define clear legal liability.
For everyone involved.
For the human executors, for the oversight role of the AI pilot, and for the technical responsibility of the system architect. We'd need mandatory, detailed audit trails for every single human override, and establish standards for defining the ethical parameters used by the validation layer. This isn't just about consumer protection anymore. It's about preparing for a future where a complex AI decision immediately impacts physical security, economic stability, and human livelihoods.
We've thoroughly explored the immense technical and ethical complexity that's required to safely manage the unimaginable command. But the real sign of a technological inflection point is when this kind of complex architecture is successfully monetized.
Right.
And the sources point to this company, SMS Novel Films, which is doing exactly that. They're turning this ability to handle complex orchestration into a scalable service.
It's the ultimate proof of concept for this whole live LLM paradigm. They are leveraging this advanced HAO architecture to offer what they call human-augmented AI as a service. The core business concept relies on combining those three necessary elements we talked about earlier, but using them to drive actual commercial results.
So let's break that down. How does that synergy work in a commercial context?
First, you've got the large language models, the LLMs. They provide the high-level intellectual capacity, the strategic planning, the recursive breakdown, the sophisticated content generation. The brains.
Right.
Second, they have the human executors. This is a distributed network of individuals all over the globe who handle the high-context physical tasks, negotiation, on-site problem-solving, filming, filing official paperwork.
The hands
and feet. And third, you have the digital platforms like the HAO console we discussed. That's the glue. It seamlessly connects the abstract client prompt to the LLM's plan and then orchestrates the human executor's action out in the field.
So the outcome is a service that doesn't just deliver a plan. It delivers a completed, personalized, real-world result. And their first flagship service, One Prompt University, or OPU, is the perfect example of this human-AI choreography in the education sector.
OPU is designed to just eliminate the long development cycle and the generic content that's associated with, most online courses. The user submits a single abstract learning goal, something like teach me advanced risk modeling in Python, or help me master the art of negotiation for mergers and acquisitions.
Okay, so that one single prompt triggers the entire orchestration system. How does the AI turn that into a lesson plan, and how is the human actually integrated?
The LLM immediately performs recursive prompt engineering on that learning goal. It develops a tailored syllabus, a structured lesson plan, specific exercises, and detailed, very current talking points. For advanced risk modeling in Python, the AI might incorporate the very latest financial models that were released in just the last few weeks. Data points that are way too new for a static textbook. But the key is that this curriculum is then delivered by a live human facilitator via video. And the human brings the crucial elements: empathy, the ability to read nonverbal cues from the student, and real-time adjustment based on their current proficiency or confusion. During the live session, the facilitator is giving feedback to the HAO through the console. They might say, the student struggled with topic 3.1, needs a deeper dive into the specific case study of X.
And AI reacts to that.
Instantly. The LLM processes that feedback and modifies the curriculum for the next 10 minutes of the session. It generates new, tailored examples and shifts the focus. So the human provides the connection, and the AI provides the instantly adaptive content.
That dramatically solves the personalization problem in education. So how are they making money from this? We need to get into the details of the monetization mechanisms.
The structure is highly optimized for market penetration. It relies on 4 defined revenue streams. First, the most straightforward is paid per session. A user needs an immediate specific skill delivered live and tailored to their prompt. Simple.
Okay.
Second, they have a traditional subscription model, which allows access to a certain number of standard prompts or learning hours per month.
Then you must have the premium option.
Oh, of course. Third, and this is highly lucrative, are the premium tiers. This could be multi-week mastery courses delivered by specialized, high-demand experts, or access to the most complex, multimodal learning prompts. A premium tier might guarantee a lower student-to-facilitator ratio, for example.
And what about corporate clients?
That's the fourth stream, and it's the backbone of their long-term stability. Corporate partnerships. This involves contracting with large companies for bulk employee training. The AI ensures every employee gets consistent, high-quality, but instantly personalized training on, say, new compliance laws or software rollouts.
The operational advantage there sounds immense. If the AI is handling all the curriculum development, the speed to market must be incredibly fast compared to a traditional university trying to design a new course.
It is. The hybrid structure dramatically reduces instructor overhead and curriculum development time. A traditional educational institution might take, 6 to 18 months to launch a new specialized course?
At least.
The live LLM can generate a high-quality, personalized syllabus in minutes, and this allows SMS Novel to scale expertise globally across virtually any topic, adapting to market demand instantly because the AI manages the content structure and the quality assurance. The human is focused solely on delivery and refinement, not all that administrative prep work.
But the architecture wasn't just built for education, it was built for those unimaginable commands. Which brings us to their other service, Prompt Realization Services, or PRS.
Right. PRS is the company translating that abstract prompt execution into high-value services across all kinds of domains. This includes examples like business launch services, start my e-commerce brand in Germany, or content production, orchestrating entire media campaigns or short films from a prompt.
And even administrative tasks.
And the very high-context world of administrative tasks and event facilitation. If a client prompts, organize a 3-day multi-city product launch event spanning London, Paris, and Berlin next quarter, the live LLM initiates a hugely complex recursive plan involving 3 different legal and logistical frameworks. The AI pilot validates the ethical parameters, and the system deploys a human executor in each city to handle the physical booking, the local vendor negotiation, and the permit acquisition.
So what does the revenue structure look like for these high-value multimodal tasks in PRS?
It reflects the complexity. They primarily charge per task or per package, and the price scales based on the number of modes involved: text, visual, physical action, legal complexity, and the geographic distribution.
I'm guessing they have rush options.
Oh, yeah. They offer highly profitable, premium fast-track options for urgent requests that require immediate deployment of human executors. And for their corporate clients, they offer a recurring subscription model that effectively lets a company outsource its ongoing operational complexity, like managing all quarterly filings or continually scouting potential expansion locations, to this human AI network.
This is a system that must demand enormous capital and technological investment. To justify all that, there has to be a definitive competitive edge. How does this model truly differentiate itself from the thousands of other AI and gig economy startups out there?
The competitive advantage is singular, and it's very explicit. Prompt to physical execution at scale.
At scale.
At scale. While competitors might offer expert consultation or a really excellent business plan or detailed content generation, none of them offer the orchestrated execution network that's required to ground those abstract ideas in physical reality. They are solving the last-mile problem of artificial intelligence.
So the differentiator isn't just the quality of the LLM's thought, but the system's guaranteed ability to translate that thought into a tangible, real-world outcome.
Precisely. The humans are tasked with the physical requirements that remain outside the digital realm: conducting complex legal negotiations, running local errands, finalizing permits, setting up physical events, or ensuring high-quality cinematic shooting. This gives clients on-demand flexibility and speed. They get personalized, concrete outcomes instantly, rather than having to manage complex teams or enroll in rigid organizational workflows themselves.
And the structure allows for a massive scalability that's usually impossible in a high-context service business like this.
Yes. The beauty of the design is that the AI handles the administrative and operational complexity of coordination. They can deploy hundreds of human executors in parallel all over the globe, managing dozens of simultaneous projects.
And the AI is the project manager for all of them.
The LLM coordinates the scheduling, manages the workflow dependencies, issues the task specifications, and uses the validation layer to maintain quality assurance. This frees up the human executor to focus entirely on the physical task at hand, while the AI manages the logistics and quality control. And that leads to a high perceived value and really reliable outcomes for the client.
Let's use the detailed workflow examples from the source material to really illustrate this seamless AI-human split. Let's take our example of the start a food delivery business in NYC prompt. What are the specific detailed splits of responsibility there?
Okay. For this complex multimodal command, the AI takes on the strategic and administrative burden. The LLM would perform first market forecasting and business planning. So it's identifying the optimal neighborhood zones, calculating the initial budget, projecting revenue growth based on demographic data.
All the upfront analysis.
All the analysis. Second, supplier identification and inventory planning. It would compile verified lists of local, current food suppliers, negotiate optimal digital pricing models, and draft the initial service agreement templates. And third, digital platform construction, generating the basic framework for the delivery app and the website copy.
Okay, so that's the AI's part. What does the human do?
The human operator, the local executor in NYC, then handles the physical and localized execution. First, local negotiation. Physically meeting with suppliers to finalize those contracts, conducting taste tests, and securing favorable, locally negotiated terms that an AI couldn't.
Right.
Second, regulatory filing. Navigating the complex physical filing process for city health permits and business licenses, which often requires in-person visits and specific local knowledge. And third, the pilot operation. Creating and managing the crucial first batch of deliveries to validate the logistics chain and provide that critical, real-world operational feedback to the AI.
It's a beautifully choreographed system. Let's look at the other example. Produce a 2-minute short film.
The division of labor follows the exact same principle. The AI handles the highly creative and technical planning for speed and consistency. So the LLM would handle script and storyboard generation, writing a script tailored to the theme, and generating a detailed shot list. Second, resource scheduling, coordinating the availability of human crew members, selecting location ideas, and drafting the initial call sheets. And third, the post-production plan, creating a detailed editing sequence and technical specs for the final cut, including color grading and audio mixing instructions.
And then the human crew comes in.
Then the human camera crew steps in for the physical manifestation. First, physical production. They're operating professional camera equipment to shoot the footage, directing actors, handling lighting and sound in real-world environments.
And the creative final touch.
And the creative oversight. The human editor performs the final cut. They use the AI's plan as a guide, but they apply their own cinematic vision and subjective aesthetic judgment to finalize the product. The human ensures the output evokes the desired emotion, which is something the LLM can only plan for theoretically.
This reveals the potential for this AI-human orchestration model to capture immense market share across several high-value sectors.
Absolutely. The identified high-value markets are staggering. Education and learning is a massive target, projected at over $400 billion, where the OPU model provides an unmatched value proposition. The gig and local services market benefits from on-demand execution of complex tasks. And media production gains incredible speed and scale through AI-assisted creative planning.
And the strategic vision ties this complex operation into a massive global future. They're currently validating the network with OPU, that's phase 1. Then they're moving to high-value fulfillment, phase 2. And then looking to phase 3, developing an API for enterprise automation, which means allowing other large companies to plug into the HAO system to automate their own high-context workflows using this human AI orchestration model.
Which leads inevitably to phase 4, creating a global network of human capacity orchestrated by AI for real-world execution. The ultimate goal here is the foundation of a prompt-driven operational economy.
A prompt-driven operational economy.
In this future, any complex, abstract human will, any unimaginable command, can be translated instantly into discrete, verified global physical action. This represents a new paradigm shift where user prompts transcend mere digital interaction. They become immediately actionable, orchestrated results, transitioning conversational requests into tangible physical reality through a meticulously designed system of human-AI symbiosis.
So what does this all mean? Our deep dive into this live LLM blueprint reveals that the next evolutionary step for artificial intelligence is not about achieving full autonomy. Instead, it seems to be about building the most sophisticated interface possible. The live LLM requires a human in the loop, not as a temporary weakness or a failure point, but as the essential adaptable component for safety, for ethical judgment, and for creative, real-world execution.
The sources make a really undeniable case that the true power ceiling of AI is reached only when it can reliably and ethically direct real-world human capacity. This infrastructure isn't just fast, it's designed for adaptive stability. It ensures that even the most complex, novel commands can be fulfilled safely and efficiently by utilizing human agents in the field.
Which brings us to the final provocative thought for you to consider, based on the future directions mentioned in the source material. We've successfully detailed the architecture that allows an AI pilot to manage a human executor filing a permit in London or shooting a film in New York. The system has proven it can ethically and structurally manage human action based on abstract prompts.
So, if the AI pilot has mastered the complexity of guiding and ethically limiting human capacity, what are the implications when this same sophisticated, symbiotic, human-operated LLM is integrated directly with fully autonomous physical systems? I'm not just talking about a single robot, but complex fleets of automated systems, logistics chains, or industrial facilities.
What happens when the AI is directing a physical robot or a complex automated system to execute an abstract command like establish a temporary humanitarian relief hub in Region X? If the ethical and 60 challenges of human orchestration are solved, the threshold for true autonomous physical execution driven by a single abstract human prompt is terrifyingly close. Think about the implications for everything from construction to global logistics and crisis response, something to mull over until our next deep dives. Thank you for joining us, and we look forward to unpacking your next stack of sources soon.